All right, so let's have a look at these problems here. So as you can see, we have information about a circle Q with the diameter whose endpoints are 0, 0, and 8, 6. We want to determine where it intersects the x-axis again. So as always, it's always a good idea to just sketch a picture of this here so that we can see what this is going to look like here. And then we can do something like, and again, we have a circle that looks like this here. I apologize for my lumpy circles, but you get the picture. Okay, so what we have here, so in this case, what we have is something like this here, where, you know, we can find the center of the circle here, right? So the center in this case is going to be the point here, like so. The center is going to be the midpoint of this diameter, because you were told 0, 0, and 8, 6 were the diameter here. So the center is going to be 0 plus 8 over 2 and 0 plus 6 over 2. And that is 8 over 2 and 6 over 2, which is the point 4, 3. So that makes sense, right? So here, 4, 3 is going to be the center of the circle here. So if we look at the equation of the center here, right, with this case, now we know that the radius, right, we can very easily calculate the radius here. This is a 3, 4, 5 triangle, so the radius is going to be 5. So that means the equation of the circle, in this case, is just going to be, let's see, it's going to be x minus 4 squared plus y minus 3 squared equals 5 squared, or 25. Okay. So now we know that's the case here. We're told that it intersects the x-axis at a second point. It intersects at 0, 0. It's also going to intersect at another point here. So let's call this point here x, 0. Therefore, we know that since the y-coordinate is 0, we can just go ahead and substitute that in. So we know 25 is equal to x minus 4 squared plus 0 minus 3 squared, right? Because we know the y-coordinate is 0. So we can go ahead and substitute that in. So 25 in this case is x squared minus, in this case, let's go ahead and write this out here, x squared minus 8x plus 16, and then we have what appears to be plus 9, right, because we have that here. Now, 16 and 9, that's 25, and there's a 25 on this side, so we can subtract 25 from both sides and get x squared minus 8x is 0. So, of course, this factors very well. So we get x equals 0 and x equals 8 here. Now, it makes sense that we have x equals 0 because in this case we knew it intersected at the point 0, 0. But also, that means now we have the fact that x is equal to 8. Take a look here. This another way to think about this here, ladies and gentlemen, is to think about this like this. You can see that the x-axis acts as a chord for the circle here. So this is 4 and 3, we can just consider this as reflecting this triangle over this vertical portion of the radius here. Get 4 and 3 as well. So that means it's also going to be 4 units away like this. So it's going to be a total of 8 units away. Okay. So in this case here, we now have the x-coordinate new point is 8. All right. Let's look at number 4 now. So number 4, we're told that the equation, the line with this particular equation here intersects a circle with this particular equation at 2 points P and Q. Let M be the midpoint of chord PQ. Show that the radius that passes through M is perpendicular to PQ. Okay, so again, we're going to go ahead and sketch this out here. This I'm going to write as y equals negative 2x plus 10, right? So we know that's going to be a line with slope negative 2 and it's going to pass through the point 0, 10. All right, so again, let's sketch a picture as always. It's always good to sketch a picture here. This is the equation x squared plus y squared is 25. Now, the nice part about this is that this is x minus 0 and y minus 0. So this circle is centered at the origin, centered at 0, 0, and it should have a radius is equal to 5. So we can draw a circle like this here. Okay, so here's my circle. This x squared plus y squared equals 25. So we know that our line is going to look something like this here. It's going to start up here, and then it's going to go down. So since there's a slope of negative 2, we note that in this case, if y is 0, we get negative 0 is equal to negative 2x plus 10. We get x is equal to 5 here. And in fact, that's actually this point right here. So in fact, our line looks something, oh, I missed. Our line looks something like this here. I apologize about this. It's not a very good looking line, but you get the picture here. So we're going to get 2 points here. Here's P and here's Q. We know one of these points is 5, 0 already. Okay? So in order to find the other point, we know that, remember, just like with the equations of lines, when we find their intersection, we just set them equal, we just solve the system here. So we're going to do the same thing. We're going to solve a system here and set it up in this fashion. So now I can go ahead and plug this in here, substitute this in here. I know that y equals negative 2x plus 10, so I can use that. So you get x squared plus negative 2x plus 10 all squared, and that's equal to 25 here. So all I'm doing is substituting this into that here, right? Because we have a system of equations. All right, so let's go ahead and write this one out here. So you get x squared plus, so let's see, negative 2x plus, so let's see, we're going to square this. So it's a squared plus 2ab plus b squared. So negative 2x squared is 4x squared. We have a minus 20x, that's our middle term, but it's going to be copied twice. So it's going to be, we're going to have a minus 40x. And then plus 100 is 25 here, right? So we're just expanding this out. So now we can just gather all our terms. So we get 5x squared minus 40x. There's a plus 100 here, so we subtract 25 from both sides, and we end up with a plus 75 here, and that's equal to 0. We note that everything here is divisible by 5, so I can take this and divide everything by 5 here. We get x squared minus 8x plus 15 equals 0. And if you remember your algebra, this is actually quite nice because it's factorable, right? And so this factors very easily, or you can use the quadratic formula, whatever have you here. This becomes x minus 3 times x minus 5, so we end up with x is equal to 5 and x equals 3, right? Now, this is going to generate us the 5, 0 that we wanted here, right? Because we knew it's going to intersect at that point. So in this case here, y is going to be negative 2 times 5 plus 10, and that's 0 here. So that's going to be 5 comma 0. That's the same idea here. Whereas over here, with this 3, we get y equals, in this case here, negative 2 times 3 plus 10, which is negative 6 plus 10, or positive 4. So we have 2 points here at 5, 0, and at 3, 4 here, okay? So P is going to be 0.3 comma 4, and now we can find the location of M. So M is halfway in between here. We can now find that M, so I'll write that over here, M is going to be 3 plus 5 over 2, and 4 plus 0 over 2, which in this case is 8 over 2, 4 over 2, which is 4 comma 2 here. So that's going to be our location of point M. And now we want to show that that is perpendicular here, okay? So in this case, here's M. So here's our radius, or at least the portion of our radius here. Here's M, and that's 4, 2, okay? Show that the radius that passes through M is perpendicular to PQ. I'm going to call the center O, and that's 0, 0 here. All right, so let's put this together. So now I have to show the slopes of the pieces here. So it's the slopes of OM. Well, that's easy. That's just 2 minus 0 over 4 minus 0, which is 1/2, which is what we want to see here. And now we can use PQ here. Find the slope of PQ. In this case, we have, let's see, 4 minus 0 over 3 minus 5, which is 4 over negative 2, which is minus 2 here. And we see that indeed 1/2 times negative 2 is negative 1. And that's a good thing. Thus, OM is perpendicular to PQ. You'll love to see that, okay? Now, number 5. Let's move on. Number 5 here. Determine the equation of a line that is tangent to the circle x squared plus y squared equals 8 at the point 2 comma 2. So, again, sketch. You don't have to do the sketch here, but I highly suggest doing the sketch because it helps you visualize the situation here. So again, note that it's x squared plus y squared is equal to 8. That's a good thing here, right? That means that's going to be the point, that's going to be at the point 0, 0. The center is there. And that means that the radius is going to be radical 8. I don't really care about the radius here. What I care about is that it's going to be at the point 2 comma 2. Now, we can very easily verify that 2, 2 does indeed lie on the circle here. So I'm going to call, again, O is the center of the circle. I'm going to call it 0 comma 0. And we know that this point 2, I'm going to call this A. This point 2, 2 is on the circle because it satisfies the equation of the circle. And therefore, our tangent line looks something like this here. Okay? So here's our tangent line. I'm going to call it L. Now, the nice part about this, you remember one of the properties is that a tangent line is always perpendicular to the radius of the point of tangency. So I can go ahead and sketch this here, so now I know what OA is. I know that. So about the blue line L, we know a point on it, we just need to find a slope. And we know the slope is going to be the negative reciprocal of the slope of OA. So the slope of OA is just 2 minus 0 over 2 minus 0, which is 2 over 2, or 1. So therefore, the slope of line L is just negative 1 divided by the slope of OA, which is 1, and we get negative 1 here. So now we have all the pieces we need. We have a point, we have a slope, so that we can put it all together. So therefore, we know y minus 2, remember that we're just plugging in the y coordinate here, y minus 2 is equal to negative 1 times x minus 2 as well. So negative 2, 2 here. So therefore, we get y minus 2 equals negative x plus 2 here. So we can add 2 to both sides. And therefore, we get y equals negative x plus 4. And this is the equation of our tangent line here.